Yes, so Owen's slides are up, and I think he's here. I can't see his video. Are you here, Owen? And am I pronouncing your first name correctly?
I'm here, you're pronouncing it correctly, and I think you should be able to hear me now.
Oh, good. Yes, you're live. Take it
Great.
away.
Thank you very much. Hi, everyone. Hi, people of the internet. I'm going to do a slightly different talk today. It's going to be one part manifesto as to why you should learn, you should at least consider learning to do things the hard way and build your tasks using JavaScript rather than any of the other wonderful tools that are available. And part how-to guide, so a roadmap to how you might go about doing that. For the manifesto side, why should you learn JavaScript? Why should you put yourself through all this pain? There's a few background points I'd like to establish before I make my argument. The first is this. So with any tool for any job, there's always a trade-off between how simple that tool is, how easy it is to learn and use, and how complex that tool is, how many things it can do, how difficult it is to get the hang of. And you can see this in any domain. So if we take data analysis as an example, Microsoft Excel is a nice, fairly simple tool. If you're doing accountancy, it is an excellent tool for the job. It's designed exactly for that. It's quite easy to use. It does that one job very well. However, Excel is not flexible. If you try and use Excel for scientific data analysis, for genomics, you run into a whole range of problems and terrible things happen. If you want to do that kind of work, you need a more powerful, flexible tool, something like Python. In Python, you can do whatever you could do with Excel. You can't do it as easily. If you want to manage your finances, I don't think you should use Python, but then you can also do lots of other more complicated things as well. Of course, this curve goes on and on. Anything you can do in Python, you can do in the C programming language, which is much more complex, much more flexible than Python. Anything you can do in Python, and therefore anything you can do in Excel, can be done in C, plus millions of other things. But it's the wrong tool for the job. It's the wrong place on that curve between simplicity and flexibility. And I'll come back to this idea. The second core idea I want to get across is something which is called the 80-20 rule. Now, 80-20 rules come up in a lot of domains. We're going to talk about the 80-20 rule in project management, which is essentially, in any project, the first 80%, the easy 80%, takes up about 20% of your time, while the final 20% of the project, the awkward things at the end, takes up about 80% of your time. I think this is an experience most people will be familiar with, and I'm going to use this as the basis of an argument in a few moments, but first we have a little bit more groundwork to do. What groundwork we have to do? Well, I have to explain how the web works, but time is limited, so I will do that very quickly. Part of the motivation for this is that I've had lots of conversations with people since the pandemic on how they should go about running online experiments. And I realize one thing that's missing is that we don't have a good handle on what the technologies involved actually are, what we're doing when we build these experiments. But very briefly, the web has two ends. It has a front end, so all the stuff, all the code that runs in your participant's browser or your user's browser, and which affects what shows up on the screen. So we have the contents of the web page, how it looks, how it's interactive and how it moves around. And this is implemented in programming languages like HTML or CSS or JavaScript. The other end of the internet is the servers, so everything that happens in the cloud. And this is responsible for things like, well, yes, sending files to the browser, storing data, processing stuff in real time. An example of this in building experiments is counterbalancing. Of course, if you need to counterbalance, you need to, on the server, keep track of what participants have already done what conditions. And these are to run an online experiment, really you need to manage both of these things. Yes. And there's various tools available to do all of this. On the front end, there are a range of options ranging from the simple, easy to use, to the complex and flexible. I think the simplest option in the world is Google Forms. If you are running an experiment that suits what Google Forms can do, you can run that experiment and you can build that experiment in about 5 minutes and you're ready to go. However, if you want to do something that's not any of the 5, 6 different formats that Google Forms provides, forget about it. Next level of complexity is graphical interfaces, so things like the Gorilla task builder, the new PsychoPy interface, so you can build experiments using PsychoPy and upload them to their Pavlovia platform, and services like Lab.js. And of course, there's plenty more here. This is really just a brief survey. There's JS Psych, which I'm sure most people will be familiar with. It's a JavaScript library for doing this kind of thing. And then there's the raw technologies that the web runs on itself, the HTML, CSS, and JavaScript that you would use to actually run your experiments. Now, these things are totally flexible. Anything that can be done on a website can be done using these technologies. It's a question of whether you need that flexibility. And I'm going to argue that in a lot of cases, you probably do, or you benefit from it. And we could tell a similar story on the back end. There's various solutions, from easy plug and play things like Google Forms to the Gorilla or Pavlovia or Jatos backends. Google Firebase, I've seen used, but I won't say any more about because I don't know anything about it myself. And then there's various kind of web development tools that you can adapt for these purposes. Classical things like PHP and SQL, or fancy new tools, which I'm not going to talk about today, like Node.js or Flask. I've name-checked a lot of things here, but I think the only real idea I want to get across is that some of these things are simple and rigid. Some of these things are complex and flexible. Why does this matter? Because, as I've said, we have this trade-off, or we have this general rule that when we're working on anything, the easy stuff doesn't take very much time, but the hard stuff does. The main thesis, the main manifesto I want to get across here is that when we choose tools to run experiments, when we choose tools to do anything really, we often make the mistake of choosing the right tool for the easy bits. So you choose a tool that lets you get most of the task done, and then spend weeks trying to do the hard fiddly bits that tool is not well suited for. What we should do in many cases is choose a tool, the right tool, for the hardest part of the job. And then it may be overkill for some of the easier things, some of the things you could do quite easily with drag and drop. But all in all, you get the job done more easily. You get a working experiment in less time and less effort. And this may even mean that you start off using something simple and rigid, and you realize you've made a mistake. You realize there's a sunk cost. It's probably may still be worth changing in these contexts. And I guess the main thing I want people to take from this talk is that you should try and recognize when that happens. You should be willing to change. You should be on the lookout for these problems when they arise. One moment. Yes. So if we take a look at the tools that people use for online experiments, I've spoken about the graphical interfaces, I've spoken about JS Psych, and I've spoken about the raw tools. The appropriate tool for the job obviously depends on what your experiment looks like, how complicated the most complicated part of your experiment is. In most cases, I would still say, despite all my bold claims, that things like the Gorilla Task Builder or JS Psych will be the right tool for the job. But if you come up against something which these things aren't designed to do, the difficulty involved in hacking the Gorilla Builder or hacking JS Psych to do what you need to do is far more complicated than the difficulty of just doing everything from scratch. That is the why. That is my manifesto. The next thing I want to cover, and I've spoken quite quickly, so I have plenty of time to do this, and I can maybe slow down a little bit, is how. So I'm not going to use this time as like a tutorial on how to use JavaScript. I think it's not too complicated to learn that. It takes maybe a day, but it doesn't take 5 minutes. Instead, what I'm going to do is use a case study from some of my current research at UCL. What kind of problems we're trying to solve, what kind of tools we're using to solve that, and some of the outputs from what we're doing. So my use case is my current project at UCL. The core of this research is, in simple terms, we want to get a load of participants to do several behavioral tasks, many questionnaires, and we want to see how different patterns of responding in the questionnaires reflect to individual differences in computational models of how they perform the tasks. We're not just going to blindly correlate things here. We have hypotheses, of course, but I don't think I need to say any more than that for the current purposes. The tools we use for this job, initially when I started out on this project, I thought I'll just do what I find easiest to use, and because I've used these kind of fancy web development tools before, I'll use these for the job. However, there are a number of new considerations here. Obviously, COVID has happened. There's a lot more interest in doing online studies, and really what we would like is something that is powerful and flexible enough to do what we need to do, but also is easy enough to teach to other people in the lab, to teach to next year's master's students when they come in, because they're all going to need projects and they're not going to learn all the hard stuff, but they maybe should learn enough of the hard stuff to get going. So what we'll instead do is use the fancy tools, so HTML, CSS, and JavaScript for the front end of the task, and interface that with the Gorilla backend, so the Gorilla metrics system and the Gorilla code editor. A few things that a person would need to be talked through in order to be able to do this. The next few slides are in no particular order because I couldn't decide what order to put them in. It's very easy to develop code if you have a code editor. There are a lot of wonderful online tools. The Gorilla code editor is quite good. There's a couple of other options, but there's really no substitute for having the files in your computer, having a code editor that lets you edit those files, and then as soon as you make those changes, you reload the page and you see the changes you've made. And yes, this allows for faster iteration of your design, more control of how things work. And of course, it's platform agnostic. If you want to run your task on Gorilla, you can run it on Gorilla. If you want to run it anywhere else, you can run it anywhere else. And as with any other tool, there's trade-offs here. You can use an editor that's specifically for web coding. So Brackets is a good choice for this, which is simple and does that one job very well. Or you can use a general purpose editor like Atom, which will take you longer to use, but can do a whole lot more things. Again, this trade-off is ubiquitous. You need to be aware of what the technologies are. I think it would take a half a day, maybe a day, to maybe cover what all of these are, but it's worth mentioning now that what makes up the internet is HTML, which defines the content of what you're seeing. CSS, which is a language that says how things should look on the internet. And JavaScript, which is the language we use to manipulate how everything else looks, so to change the content, change the appearance, and so on. Yes, and with these, we also have access to things like multimedia input, multimedia output. So we've seen a lot about how you can record video. You can show people video, you can record video from participants. There's plenty more we can do with this. So we can access, with mobile browsers, we can access the front and back cameras. We can access the accelerometers and gyroscopes. We can use the vibrators on the device. There's anything you can do on a website, you can do in your experiments if you're willing to put in the work with these technologies. I have time to indulge in a little bit of talking about some current projects we're working on.
No, actually, at this point, I think that we're running over. So it'd be great if you could just sort of put a conclusion on it.
Am I not on 7 minutes?
No.
I see. In which case, I won't indulge. I'll say two very quick things. So the biggest challenge in all of this has been integrating the new tools with things like Gorilla. So integrating your own code with Gorilla. And I'm going to very briefly advertise two tools you can find on GitHub. One is a JavaScript library called Primate, which provides an easy interface with the Gorilla API with various advantages, which I don't have time to go into. And the second is a tool called Gorillify. Now, Gorillify is a very simple command line tool. You give it a project, some HTML files and JavaScript files, and Gorillify gives you step-by-step instructions to turn that into a Gorilla experiment. That's all I have to say. Very quickly at the end, thanks to everyone at Gorilla for organizing this. John Roiser and the ICN Neuroscience and Mental Health Group for paying me to do this research, and the Wellcome Trust for giving him the money to do that. And if you have any questions about any of this, this is how you can get in touch. Thanks.
Thank you very much, Owen. Yeah, as an old-time C programmer, this